Section 2.3 is about biconditionals and definitions. So a biconditional is a statement that's going to use the words if and only if. So it says a single true statement that combines a true conditional and its true converse. So just making sure you know that it uses the words if and only if. The other thing that we're going to use is talk about a good definition. And a good definition can be written as a biconditional. So let's look at the first example. It says, what's the converse? If the converse is true, rewrite the statements as a biconditional. If the sum of the measures of two angles is 180, then the two angles are supplementary. So remember, converse is where we're going to switch it. So we're going to say, if two angles are supplementary, then the two angles add to 180. That is true, so I would rewrite it as a biconditional. So biconditional means take off those words if and then, and we're going to put if and only if in between here. So two angles are supplementary if and only if the two angles add to 180. So notice I just took off the words if and then, and I put if and only if right here in between the hypothesis and conclusion. Alright, your turn. Pause the video and try the got it question. So my statement is, if two angles have equal measure, then the angles are congruent. The converse says, if two angles are congruent, then they have equal measures. That is true, so my biconditional would be putting if and only if right here in between the hypothesis and conclusion. So two angles are congruent, two angles have equal measure if and only if they're congruent. You can also rewrite it the other way. So notice that I've showed you where you can use the converse to write your if and only if, or you can use the conditional statement. Either one, it's the same thing because biconditionals are reversible. Alright, problem 2. What are the two conditional statements? So suppose they give you the biconditional, you have to come up with the two conditional statements. So that just means if I had this, a ray is an angle bisector if and only if it divides an angle into two congruent angles. I would just take out this if and only if and replace it by putting if in front of the hypothesis and put then right here where I have my if and only if. So one conditional statement would say, if a ray is an angle bisector, then it divides an angle into two congruent angles. So notice I just put the word if there and took this out and put the word then. The other conditional statement is when you would flip-flop it. So the other conditional statement would be if an angle, if, for some reason I don't have this wrote here, if a ray divides an angle into two congruent angles, then it is an angle bisector. So the two conditional statements would be the conditional statement with the word if and then in there, and then just reverse it. So then you are just doing the converse of that. So you're writing the conditional and the converse of what you just wrote. Sorry, you can't see that. Okay, your turn. Try writing the two conditional statements based off the if and only if. So my statement is two numbers are reciprocals if and only if their product is 1. So one conditional statement would be just like it says. So if two numbers are reciprocals, then their product is 1. So take out the word if and only if, put the word then, put the word if in front. Now just do the converse of that. If two numbers' product is 1, then there are reciprocals. Alright, good definition. So remember, we can use a good definition to come up with a biconditional. So a good definition has to use clearly understood terms. The definition has to be precise, so don't use words like large or almost. And it can be reversible, or has to be reversible, which means it can be written as a biconditional statement. So here's our first example. Is this definition of quadrilateral reversible? If yes, write it as a true biconditional. So reversible means that if I were to switch it around, it would still be true. So if a polygon is a quadrilateral, then it has 4 sides. That's true. What if I reversed it? If a polygon has 4 sides, then it's a quadrilateral. That is true. So it is reversible because when I did the conditional and the converse, both of them are true. So then the biconditional is when I put in that if and only if. So a quadrilateral is, or a polygon is a quadrilateral if and only if it has 4 sides. Alright, pause the video and you try it. So here's the definition. A straight angle is an angle that measures 180. So I check the conditional. If an angle is a straight angle, then it measures to 180. True. If an angle measures to 180, then it's a straight angle. The converse is also true. So, yes, it is reversible. So now I'm going to write it as a biconditional. So, an angle is a straight angle if and only if it measures to 180. Alright, one more way to show that a statement is not a good definition is when you find a counterexample. So, it says, which of the following is a good definition? My first one is, a fish is an animal that swims. Well, a whale also is an animal that swims, so that doesn't really be specific. Rectangles have 4 corners. Again, it's not very specific because a square also has 4 corners. Giraffes are animals with very long necks. Again, there are also ostriches with very long necks, so not specific enough. So then last, a penny is a coin worth 1 cent. There is only one coin that is 1 cent, and that is the penny. Pause the video and try the next. So which of the following is a good definition? Or is the statement a good definition? A square is a figure with 4 right angles. This is not a good definition because I can think of something else that has 4 right angles, and that is a rectangle. So no, because a rectangle has 4 right angles. So good definitions can be wrote as biconditionals, but if you can find counterexamples for your definitions, then it's not a good definition.